Hi there, I'm TechBot, your friendly tech store assistant. How can I help you today?
Hey, actually, I went to your store and I bought this device. If you can see from the screen, from your camera.
Let me take a look. It looks like you have a MacBook. How can I assist you with it?
Yeah, I bought this. It's not charging anymore. I just need a charger. Do you know how much does it cost?
Sure. Let me check the price for a MacBook charger for you. Can you also tell me the model or year of your MacBook?
Yeah, this is the 20 MacBook.
For a 2020 MacBook, you'll likely need a USB-C charger. Let me check the current price for you.
Did you get it?
The price for a USB-C charger for a 2020 MacBook usually ranges around $50 to $70. Prices may vary depending on the retailer and specific model.
Thank you.
You're welcome. If you need more help, feel free to ask.
So that was really fun, isn't it? A couple of days back, one of your viewers have asked me through one of the YouTube video comments that is it possible to do the live stream avatar as a voice AI agent or multimodal AI agent? And to that, my answer was, sorry, it's not possible because all the top provider that we have out there, which is like Hagen or Synthesia or something, they are basically batch or job based. That means you cannot really do a live stream of avatar through those APIs as of yet, at least. But that kept me on thinking that is this really not possible? And so I kept on researching, and I think I found out not the best possible answer, somewhat working solution, as you have seen probably in the demo, where we have created an avatar, which is really a very tricky way. Now, I'll show you later in the code tutorial to do some kind of video streaming as if when you're speaking with the voice AI agent. And as part of this video, we are going to deep dive into that code base, of course. And maybe in the demo, you have seen that it was a bit lagging. It was not so fluent. That is because I was running so many things in my local system to run this demo, from the server to run the vision model, to run the recording software and a couple of other browsers. So that is why it was a bit of lagging, but in a real test scenario, it was really, really smooth and I really liked it. So that's why I thought I'd create the video. But this is one of the reasons why you must subscribe to the channel and let me know your need through the comments in the video, what you're trying to build or any of your idea that you're struggling with, so that I would know your learning need and I can bring this kind of video in the channel. So again, must subscribe to the channel, and let's go to the screen and let me share you the code deep dive as well as to show you how you can build this kind of AI agent for your own business use case. So shall we go to the screen? Welcome to the core tutorial, and this tutorial is going to be a very, very heavy knowledge oriented. The reason is because we are going to cover so many things in this tutorial. So please stay focused, and if possible, watch this on a big screen, especially maybe in your laptop or something. And it would be even better if you can actually follow through by downloading the code, because that will even give you some more detailed idea about how to run this kind of multimodal AI system. Because if you just watch it on a phone or something, probably you're not going to get it on the first time. So in this video, we are going to run pipecat, of course, because truly I have been so much biased about LiveKit for so long time, but now as I am exploring the pipecat project more every day, I am really falling in love with this project. I'm actually seeing a lot more features or a lot more use cases out of this pipecat project as I'm exploring this one, and I'm probably gonna bring a lot more videos on this project going forward in the channel. So we are definitely going to use this pipecat, which is an open source framework. We are going to use a vision model, which is also an open source, plus we are running the vision model locally. So if you have any kind of use case which is privacy oriented, where you want to run an AI agent in a control scenario, or so you cannot share the image input or the camera feeds or something to a public model, and you need to really keep it in a like a controlled environment, this video will actually show you how you can actually run a visual model locally and use it in your AI agent. We are also going to use OpenAI, of course, as part of the voice processing, but we are not using OpenAI's vision model. If you have seen the demo, we are using the locally running vision model. We are also running Cartesia here as a text-to-speech provider, which is first time I'm exploring this. And I was really happy to use Cartesia because I saw much more improvement than I have used 11 Labs before. No discredit to 11 Labs, of course, because I love the way 11 Lab work. Their voice output is much, I would say, mature or dynamic. But yeah, Cartesia is also one of the really great TTS that I have been using. And I have not been paid by any of these providers. So this is really my individual opinion so far by using these tools. Apart from that, we are also going to do tool calling. So it's doing the price check as you have seen. So it's using the tools to get the prices and everything. So this is a really, really comprehensive AI agent system, and which is truly multimodal in nature. So let's go to the code and let's explore one by one. It's not a huge code, but there is a lot of really tricky things that you need to understand how the entire thing is working. So here we are into our code. So before even I proceed through the code, just want to be really, really transparent that the entire code base is not my own creation. I have taken a reference from this particular Moondream chatbot project that I have found out as I was researching about how to feed voice output by the AI agent, and I could find this project kind of really serving the need in a very tricky way. And that's why I started exploring this. But if you download this project directly and if you want to run it, it will not run. There you will face some issues, and that's what I have also fixed it in my code or in the revision code. And you'll find the link for my code as well as from the description of the video for absolutely free, no question asked. But again, if you want to try out, this is the pipecat open source code base where you go to examples and you go to the Moondream chatbot where you find the original source code from where I took the inspiration and improved upon it for this particular use case. Now let's go to the code base. So as always, whenever you check out any code, we should go step by step. So the first thing we should go is the main method, because that is the method that is run first whenever you start up this kind of program. So we go to the main method, which is calling this particular main method, and let's go through one by one what is happening. So first line, we are creating a transport. So what is transport? So we are basically establishing a WebRTC connection, and we are using daily.co here, as I have already explored in one of the other pipecat video. If you have not watched it, please go to that video. I'll attach the link of that video in the description as well. But just to give you quickly run through how you can get access. So just go to daily.co, this website, and just click sign up daily video. I have already logged in, and there if you can sign up and just it doesn't need any credit card or anything. It's absolutely free. You can use up to 50 rooms and you have up to 10,000 minutes for free, which is really, really awesome to do any kind of testing really. And you go to developers and you create an API key. This is the API key that I have used in my project. Of course, I'm gonna recycle it after this demo. And then you have to come here. You can create a room here, or you can use the code that I have used, which will create the room dynamically. But please feel free to create the room here, and then what you have to do is come here in the .env file, and here you update the room URL. If you want to use one room again and again for the demo or for your trial, but if you want new rooms to be created, it really doesn't matter because it will use the daily API URL by itself. That's how the bot is written. So it will generate new room every time. You would also need OpenAI API key. I'm not showing how you get an OpenAI API key because that's really simple. Just go to the platform UI and get an OpenAI API key. You need the daily API key, exactly what I have shown you from the developers menu, and then you also go to Cartesia and get your free API key that will give you up to 10,000 character text to speech, which you can use for your trial. Now I'm not going and doing that. That will unnecessarily extend the video. Please go ahead and do that. If you face any issues, let me know in the comments and I will help you out. You would also need the Hugging Face token, which is not being talked about or been explored in this original code base. You would definitely need it if you want to run the Moondream model locally. So Moondream is a vision model that you will get it. So that's the model which can detect car, which can do a lot of things, but it's a very small model. As you can see, there are 0.5 billion model, which is a very tiny model, and you have a 2 billion model, which is also, I would say, really, really model, because a vision model running on 2 GB memory is really, really crazy. But yeah, you can run it, and the best part is you can also run it in a CPU machine. So if you do not have a GPU or something, you can still run it. I am running it on my Mac Mini M4, you can imagine, which is just a 16 GB variant, which is the base variant, and I'm still able to get a really good response. So you will definitely be running it. Now, coming back to the code, there are a couple of things that is happening here. We go to that main method. So here we need the room URL, the token that we have provided, and then we need to specify a few of the parameters based on your use case. So in this use case, we are using full-fledged multimodal use case. So that means we need camera, we need speech, we need Celero VAT, which is a voice activity detection for speech synthesis or like any speech detection. So we are using so many things. So we are using audio out, which is enabled. We have camera out, which is the output enabled. Why we are having camera out enabled? Because we are set up this AI agent to stream video, as you will see soon. That is why we need camera out width and height. And then we have transcription, which is also enabled. We have VAD, which is voice activity detector, that is enabled. We have camera in enabled. That means camera in is when I am feeding my camera feed into this particular AI agent through the WebRTC channel that is provided by Delicio. That is enabled, and it sees the width and the height of the camera. We are using the Cartesia TTS service for text to speech. You can use 11 Labs, you can use anything else, that doesn't matter, but Cartesia was really good in this example. As you have seen, the response was very quick, and that's what I saw with Cartesia. But again, I'm not promoting Cartesia or anything, and I have not been paid. It's just I've used this for this particular demo as it was there already in the original code. We are using OpenAI LLM service. We have defined the OpenAI API key, and we are using GPT-4o model for this particular demo. But we are not using the vision capabilities of GPT-4o or GPT-4o vision. We are using our own local vision model that I have just shown you. How we are doing it, I'll just show you quickly. We have created a function which is get product info, and this is written as a product tools. So if you come here, this is where we have defined a product info function. So this function is kind of the large language model. So that means every time this agent is calling OpenAI GPT-4o, it is sending this particular function. Now we have a talking animations. This is the video part. Really come to the talking animation code really soon. We are using sentence aggregator to aggregate all the sentence, and as I told you in the previous video that in pipecat we process everything as frame. So this is all pipecat processor. So sentence aggregator is a processor. So I have talked about 3 components in that video. Please go ahead and watch the video. So we talked about frames, we talked about processor, and we talked about pipelines. These are the 3 really important and most, I would say, basic terminology that you should know if you're using pipecat for your multimodal use cases. I will come through these particular functions later on. Let's first see how we are loading the Moondream model. So this is the code where we are loading the Moondream model. So this is a customized code. It was not available in the original code base. And for that, we need Hugging Face tokens. So go register in Hugging Face. I have done it numerous times in the previous videos. Please go ahead and check those videos. Maybe if you're not sure, I can actually show you very quickly how you can do that. So just go to huggingface.co, register yourself if you have not, and then from here go to access token, and then just create an access token with the write access. Maybe read access will work. For testing, I always use write access. Later we can do fine graining of the production case. We definitely want to find. Now why we need this token? Because we need to download the Moondream model locally, and that is why you need the Hugging Face token to download the Moondream version 2 model. So this is the step where it will download the model. For the first time you are going to run this demo. It will take some time because it's around 4.7 GB size of the model, which will run locally in your system. Now coming back to each of these functions. So let's see the talking animation function, and this is really way that is actually doing the talking animation. And now what is happening is this class starts a talking animation when it receives the first bot started speaking frame, and then it returns to quiet sprite when it sees the bot stopped speaking frame. So as I said, in pipecat everything is frame. So when bot starts, it gets a bot started speaking frame, and whenever the bot started speaking frame is received into the pipeline, it will call the talking animation, which will actually do the animations that you have seen in the demo. When the bot was animating by shaking its head, that you have seen, and I'll just show you the actual logic of it very quickly. So these are all maintained with Sprite. So Sprite is also a frame that is provided by the pipecat framework. So that's the sprite frame. So what we have done basically is very, very simple and very tricky, as I was saying. So we have created a sort of list, and in the list, what we are doing, we have appended in that list the raw frame. So we have around 26 images, and all the 26 image we have appended into the list. And this particular list, or as sprite frame, is actually being run in the runtime. So how is it we are doing it is here, if you see, we have bunch of frames here. So if you see every frame, so it was like a video that we have split into 25 frames, as you can see, so that you have this kind of head shaking kind of animations when it is run in a faster mode. That is what exactly is happening. There is nothing like we are running any video or anything. It's a really tricky way that we are doing it, and that is what is being run when you run this talking animation class or talking animation method. So what that is the talking animation thing. Sentence aggregator is basically just aggregating all the sentence, the system prompt and everything. I have already explained it in the previous video. Use image requester. This is a really important function that you need to understand, so please listen it carefully. If you do not use this IR when we defined our pipeline here, so you see there is an IR, what actually happens is, because we have our camera feed on, it will continuously send the camera feed or the images for a model continuously. And what will happen as a result, it will try to process the frame every time it receives a request, and you will not get what you want. So we want to control when it needs to process a frame or an image frame, or when it doesn't need to process an image frame. So that is where we need the image requester method or class. So in image requester, if we go there, if you see here, we are doing really, I would say, a rule-based framework. So what we are saying that if a frame.text contains user request answer, what is user request answer? Which is, let me take a look. If the frame that is coming out from the bot contains this message, let me take a look, then and then only we are going to request an image. So we are then and then only we are pushing the frame with the user requested frame, which is the image from the camera feed. We are not sending frame at each and every request. That will save our cost. That will save this agent to function well and properly. Otherwise, it will not work properly. So you can try it out. You can remove this function, or from the pipeline, you can remove the IR, and you will see how bad it is working. So it will just continuously keep on say, I cannot process this image, or I am seeing a person. If you have a person in the camera, and it will not process any person, because that is what not is allowed in the APIs unless you override it. And I think so that is why it was not processing the image when I was running without this particular method. We have a vision controller and we have a vision aggregator, which does the very same thing. So vision controller is basically just looking for phrases in the user prompt. So if I see, can you look, take a look, what do you see, check this, look at the whatever. So whenever it find any of this phrase, it basically knows that user is requesting the agent to look at the camera, and then the AI agent says that let me take a look, and when it says let me take a look, then it actually takes the feed from the camera. That is how it is working. And then we have the vision aggregator, where we are aggregating the image frame and the text input, and then we are sending it to the model to kind of process it. But not just that, in the aggregator class, what we are also doing is we are processing the image using our local model, and then we are getting the gist of what is there in the frame. We are sending that to the GPT-4, and in the GPT-4 we are actually doing the processing. So this is how we are doing entirely in this particular demo. Other than that, it's very simple. We are using a system prompt. We have specified reply with only user request answer. If user asks you to describe what you see, that means even if a GPT-4 model gets an image, it will always first respond the user request answer, which is the let me take a look. And when let me take a look is spoken, that is in the frame, then only it will see through the camera, and then it will process it using the local model, send it back to the GPT-4 model for whatever is in the image description, and then it will come up with the answer. we are doing all this context aggregation and everything here as part of this pipeline. This is really, really important. And again, I have described our pipeline previously in the pipecat detailed tutorial. Please go ahead and look for that particular tutorial, which was around 2 or 3 videos back. That will give you some more understanding. And that's it, really. There is nothing else on the first participant join. We have started capturing the transcription. We have started capturing the video, and we are basically just processing it using the pipeline runner. That's all that is happening here. We have a server.py and runner.py. These are basically just calling the bot.py to make it works. Like the server.py is mainly useful when you are creating the room and when a participant is joining the room and keeping the status of the room. And the runner.py is something that you would need to get the token and everything from the daily.co API, and which will be used by the server.py to create a room and then get into the room to do all the communication with the agent. Again, all this code will be available in the link for absolutely free. So go ahead, download this, run it. If you face issues, let me know in the comments. Most importantly, if you have any other similar requirement that you are facing with or you want to implement, let me know in the comments of the video, and randomly I pick up things that I am also working on probably and you are also working on, so I can actually bring a video on that one in the near future. With that said, I'm going to end this video. I really hope that you have learned something really new, and this will help you do stuff that you want to do. And if you're still here, thank you for watching the video so far, and please take care, and I will see you into the next one. Bye.